So question one, it's asking for the properties of magnetic forces and gravitational forces. If you look at option A, magnetic forces, they attract and repel, and gravitational forces only attract. So we can immediately see it's A. But if you want to look at the others, gravitational forces, obviously they don't neither attract nor repel, and magnetic forces don't only attract, things like that. And gravitational forces don't repel. Electric field between two parallel plates. So this is the formula E equals V. Finding the voltage, so ED, and it's just 2 times 10 to the minus 4 multiplied 2 comes to 2 times 10, 6 volts. B. So forces and vector question. So this it goes this way, the force this way, and so this one's this way. That way. So the vector comes to that. So it's answer A. Question 4. The magnitude of the acceleration due to gravity. It's twice the mass and half the radius. So we put into 2 gm over squared, which comes to 4 times 2 gm squared. That's 8 g. Question 5 is just asking us to label the diagram. So, X, the current is coming this way, so X is the primary coil, so these two already gone, and Y has to be a secondary coil, and the function is going from 10,000 turns to 6,000 turns, so it's a step up. B. On the RMS current, we have the voltage, and we have the voltage on the other side, 40 times 6, and 6,000, that's 1 to 6 ratio. Equals IR. We can find the current in the secondary side. It's V. Well, and 6 times 40 is 240. And the resistance is 1,200. You get a current of 0.2 amperes. And then when the current is going, current is going this way, it has the inverse of the ratio. So it's multiplied by 6 instead of divided by 6. 0.2 times 6 is 1.2 amps. So you have the frequency is halved. So the period will double and the amplitude will halve. So A, we're getting even more periods, and so it can't be A. B, the amplitude is still the same, so it can't be B. C, again, there's more more periods. And then D, the period has been doubled and the amplitude has been halved. Electric power, so the generator is turning clockwise. magnetic flux over time. So which one has the voltage and the right magnetic flux? So the voltage, if magnetic flux starts over here, it'll be the negative gradient of that. So we have a cos graph, and then it gives a negative sign, and then to do the Lenz's law gives actually a positive sine graph. Okay. Question 9. Okay, question 9. So that V1 is the speed of light in medium 1, V2 is the speed of light in medium 2, V3 is the speed of light in medium 3. So if we can draw the normal in, in medium 1, the light is refracted closer to the medium, towards the medium. So N1, N2, N3. So then that must mean that N1 is less than N2. And this is moving away from the normal. So N2 and 3 is greater than N2. And COV. So using this, N's are N2, and then N1 and N3, but it's inversely proportional to velocity. So with velocity V3, V1, V2. So that is D. The minimum value of the liquid refractive index, so that light will just cross the interface into the liquid, is closest to. And we have angle of incidence. So the closest number, it would be closest to the what do you call it? So it just goes like this, and for that, sine is this angle of 9 degrees. And glass into the liquid, and 1 into sine 90 equals N1 sine 62. You don't know N2, sine 90 is 1, N1 is 1.75 sine 62, which comes to around 1.55, and that'll be our minimum value. Ultralight aeroplane of mass 500 kilograms. It's a constant speed, 1 meter a second, and the resistance force is 1,500 newtons. So constant speed, F net, 0. So the forward thrust has to be 1,500 newtons. Small ball is running at a constant speed, falls off the edge. Which one of the following statements about the motion of the ball as it falls is correct? The ball doesn't travel at a constant speed because there's acceleration going, and won't increase at a constant rate because there's vectors going on and it's a downward force. the momentum of the ball is conserved. There's again acceleration, and so we know that it's just G acting on the ball. Joanna is an observer. Ship B flies past 0.943c. Ship is the length in FM, so length is 150 meters. We need to find L equals 0. 0 is it's lambda. 150 times Lorentz factor is given 3, which is 450 meters. Electrons of mass 9.1 times 10 to the power negative 31, sorted to speed of 1 times 10 to the power second. And they're asking for the de Broglie wavelength. Formula for de Broglie wavelength is H over P over mv. And that will come to 7.29 times 10, 11, which is C. Electrons pass through a fine metal grid, forming a diffraction pattern. The speed of the electrons is doubled using the same metal grid. So speed is doubled. Again, looking at the de Broglie wavelength formula, H over mv. Lambda is inversely proportional to velocity, and fringe spacing was lambda d. Fringe spacing, it's proportional lambda. So doubling the speed would decrease wavelength. Decreasing wavelength would decrease fringe spacing. Question 16. Photoelectric effect experiment. They shine light of a known frequency to the metal and measure the maximum kinetic energy of emitted photoelectrons. They increase the intensity of light. And we know that intensity doesn't affect the kinetic energy, so it can't be C. And these two. And we know that with intensity increases the current that we find, so more photoelectrons are being stopped, and they'll be of the same kinetic energy. Which one of the following is true when incandescent light is compared to laser light? And incandescent light doesn't have a very narrow spectrum. It's white light. Both laser light and incandescent light have a very narrow spectrum. Again, incandescent light does not have a narrow spectrum. Laser light is incoherent and incandescent light is coherent. Incandescent light isn't coherent. There's multiple wavelengths going on in there. And so it's D. Students, okay. Students use a constant mass and constant amplitude of swing, changing only the length, measuring time. Each of the following best identify the independent, dependent, and controlled variables. So the measuring the time. So that will be our dependent variable. So this. they are controlling the mass and amplitude. So it can't be this. It's the only one left, is it? Which one of the following best explains why students measure the time for 5 oscillations rather than the time for 1 oscillation? It doesn't matter if 1 oscillation is too great to see. It's not the best answer for this. 5 oscillations I wouldn't even know that, but yeah, 5 oscillations reduce the uncertainty of the measured period, or 5 oscillations reduce the uncertainty of the measured length. We're not measuring the length. It's already changing. It's not this. What is C? It is. As part of the physics course, Anna, Bianca, Chris, and Anshiro investigate the physics of car crashes. So they say the crumpling action works to absorb some of the initial crash forces. So what the word forces in this statement mean? It does, we can't say absorbs initial crash speed. Doesn't can't absorb momentum. And in the crumpling, it's absorbing energy. So in the answer, we had to talk about energy, and the only one with energy is B, with kinetic energy. Charge be positive or negative. Yeah. So you know that this force onwards, and we need to figure out if Q is positive or negative. And then if you use using right hand rule, we can see that using our thumb that the current has to go to the left. So then the particle will have to be negative. Explain whether the part of the particle is an arc of a circle or the particle is in the magnetic field. So there's, again, we saw using the right hand palm rule that there are forces at right angles to motion, and this force is constant. Creating circular motion. Positive stationary charges, so they're repelling each other. Draw like this, and the arrows have to come away from the particles. And it's asking for 8, we did 4 for each one. Which wasn't better than that. It's a DC motor. Which terminal of the commutator is connected to positive terminal supply? So current is going, we can see that the current is going this way. So then X must be positive terminal. Draw an arrow in figure 3 to indicate the direction of magnetic force inside JK. Again, using right hand palm rule, current is going this way, magnetic force is going this way, so force is down. And the role of the commuter in the operation. It shows when D is rotation by reversing direction of current every half turn. Current of 6 amps flows to 100 turns of the coil. The side is 5 centimeters. So F equals N EI. So turns, 100 turns. The B field is 0.45. Current of 6 amps. Length is in meters, 0.05. So 13.5 newtons. Okay. Numerical value of y. We can just use our knowledge for this, and we know that near the Earth's surface, R is just the biggest Earth. We know that it's 9.8 value for gravitational acceleration. Explain why the gravitational field is 0 newtons per kilogram of the center of the Earth. So at center, there are equal masses in all directions. So vector sum of gravitational fields is 0. It's something like if you're in the center, you're attracted in every possible direction. Calculate the increase in potential energy for a 75 kilogram person, hypothetically moving from the center of Earth to the surface of Earth. So for that, it's just this area. And the energy, potential energy is half 0.5 times the radius, 6.37 plus 6 times the height is 9.8, and then we had to multiply that by how much the person weighs, which is around 4. Let's check that. Yeah. It's 9. GPS consists of 31 satellites that orbit Earth. One satellite of mass 2,270 is launched into circular orbit at an altitude of 2,000 kilometers above Earth's surface. Types of forces and the direction. So, if it's orbiting, it's just gravitational force. Gravitational force on satellite force is towards Earth. Calculate the period on satellite to 3 significant figures. Okay. Okay. Period is 4 pi squared. Radius GM. 4 times pi squared times the total radius. 6.37 for Earth's radius. 3 times 10 to the power 7 cubed. Gravitational constant is 6.7 times 11. The mass Earth is 5.8 10 24. The 3 signal figures 4.6 times 10 to the power 3 seconds. Calculate the power drawn by the lighting system. We can use P equals V squared over R. 12 squared over 12, which is 12. Someone installs an ideal transformer. Reduce the voltage from 240 to 12. Someone then runs a 200 meter heavy duty outdoor extension wire, which has a total resistance of 3 ohms. We know that the lighting system has 12 ohms. One possible reason the lights are a little dimmer than expected. Maybe one possible reason. So one reason is power transmission transformer maintains power but since it's step down it increases current. at this bed, power delivered is less than 12 watts. So we can find new current. I is, we have V over R. Yep. Voltage is 12. The total resistance is 3 plus the 12 for lighting. Is 0.8 amps. And the power lost is 5 squared over R, 8 squared times 3, 1.62 watts. So we show that the power is lost and the lights won't get the 12 watt. Using the same equipment, what changes could the homeowner make? And using the explain what changes and explain the answer. So the change they could make is they could place a transformer at the entertainment area as a step down transformer. So we get high voltage transmission, less power loss. There's slip rings and it's being turned, so it's an alternator. Magnetic flux in this position, yeah, 0. Explain it. Right. Plane of loop is parallel to magnetic field. Students connect output terminals of the piece of electrical equipment to the oscilloscope. One student rotates the loop at a constant rate of 20 revolutions per second. You have the frequency when you define the period. So T equals 20, 0.05 seconds. Calculate the maximum flux to the loop. Flux is VA. To give us the dimensions and the strength, B field strength. .5, 0.25, 0.4, yeah, 0.05 able. So the loop starts in the position shown in figure 5. What is the average voltage measured across the output terminals for the first quarter term? Voltage is in T. There's only one term, and the flux goes from 0 to 0.05, and this is I find for one quarter, for one rotation. So you divide 0.05 by 4 to get 0.025. That comes to 4 watts. To raise the amplitude of the wave, voltage across the output terminals can be increased. So how to increase the voltage? Good. Increase the frequency of rotations. Second, could increase number of turns or loops used. So that's 2. Figure 1 shows the output voltage, and then they replace the slip rings with the split ring commutator. Check 2 complete revolutions. Just draw onto this. It's a commutator now, so it's rectified. It's in the positives. Change anything else? $250 gram per car performs loop in the apparatus. And at B, 3 meters second, radius is 0.2. Calculate the value of H. You can use energy conservation for this. So G, gravitational potential, and then at point B we have gravitational potential and kinetic energy. So mgh, gh2 plus half m squared. Get rid of all the mass. It's half b squared. 9.8 h1. Trying to find h1. 9.8. 0.4. This 0.4 plus half. Velocity at b is 3 meters per second. It's good. H1 comes to 0.86 meters. Calculate the magnitude of the normal reaction force on the car by the track when it is at point B. Point B, F net would equal to the gravitational force plus the normal force. So F net is circular 2 over mg plus fn. Mass is 0.25. It's at speed of 3 meters per second. Radius is 0.2. The centripetal force, again 0.25. We take as 9.8 plus Fn. And Fn comes to 8.8 newtons. Explain why the car does not fall from the track at point B when it is upside down. So for this to occur, centripetal force has to exceed the weight force, and this comes from a normal force downwards at 10 meters per second. And we have momentum conservation. P initial equals P final. M1 V1 equals M1 V1 plus 4 1 V2. And we're trying to find initial speed. So M1 is, and we take this direction as positive, and so minus 0 times 10 to the power 6 M1 plus 4 times 10 to the power 6 4 M1, and we can cancel out the masses, get a momentum of 1.0 times 7 per second. No air resistance should be time of flight. Highest point is equal to 1.6 seconds. V equals U plus ET. At the highest point, velocity is 0. Initial velocity is 25 sine 39 plus 9.8 t. Rearranging for t, we get 1.6 seconds. Calculate the range of the projectile. We can use another constant acceleration formula. Equals half AT squared for the horizontal. So initial velocity is 25 cos 39, and the time will be double it at the highest point, so 2 times 1.6 is 62 meters. As the second postulate of Einstein's theory of relativity, let's say that speed of light is a constant all observers. And then we talk about the classical physics, how it sees the speed of light. In classical physics, speed of light is affected by relative motion between the source and observer. Speed of light increases approach decreases in retreat. Calculate speed of the wave, and we got for maximum displacement to 0 is 0.12 seconds, and for velocity is v over dt. The distance of a wavelength is 1.4. By the time it takes a one wavelength, so that's 0.12 times 4, 2, which is 2.92 meters per second. Determine the wavelength of the transverse wave traveling along the string. So for wavelength is the frequency. The velocity is 40. Frequency is 7.5, which is 5.3 meters. The standing waveform. The string string length is not multiple of lambda divided by half. So no. Yeah. The distance from S1 to P3 is 72.3 centimeters. Distance from S2 to P3 is 8.6. We can find the path difference is 80.6 minus 72.3. is 8.3. And for this path difference, we can find the wavelength. Find P3, that's 1, 2, 3 for N, 8.33 lambda. Lambda is 2.77. Frequency C over lambda. C over 2.77 is 1.8 to the power 6 hertz. Signal strength is at a minimum approximately midway between P0 and P1. So here. And when it's talking about minimum, we're talking about destructive interference. And path difference is lambda divided by 2 for this first destructive interference. Destructive interference. Because between P0 and P1, the path difference is by 2. Microwaves must also are polarized. And what is meant by the term polarized? Polarized, it's constraining oscillating elements of a transverse wave plane. If you have to draw a diagram, be something fine. Going into polarizer, which is only them. So only one plane would remain. Name and explain the effect observed by the student. Dispersion. So white light has different color. Light waves with wavelengths. positive index for class is different for different wavelengths. The fract at different angles exiting at different angles. Point X and Y. So X would be X refracts less and Y refracts more. So X would be closer to invisible light, X would be closer to red, and Y will be closer to violet. It's photoelectric effect. Asking for Planck constant, which is the gradient. We can choose any 2 points in the graph. I'll just take 1.75 minus 0.75 over 7 minus 5 times 10 to the power 14. And this is in electron volts. So get 5.10. 15 electron volts. Because electron volts seconds, which is 0 times 10, 15 electron volts seconds. Maximum wavelength of light that would cause the emission of electrons. So it would be at this point, frequency would get there. Yep. Number is CF 8 over is the I guess around 3.8 times 10 to the power 14. It comes to around 789 nanometers. The work function, you can extrapolate this. It's hard to do here. But okay, it'll get to around 1.8 electron volts. So like around here. And the work function is halved. So we had 1.8 electron volts for the work function. Halving it, it'll go to like 0.9. And the Planck constant is the same, so it'll be parallel to this line. And it's hard to do on. Try again. But like actually make sure it's parallel. Students are comparing the diffraction patterns produced by electrons and X-rays. Just spacing of the bands patterns, and explain why electrons can produce the same spacing of bands in a diffraction pattern as X-rays. So start off by saying diffraction patterns depend on wavelength, electrons can behave as waves and have a probably wavelength. Probably wavelength is equal to X-ray wavelength similar spacing is observed. Calculate the frequency of X-rays that would produce the same spacing of bands in diffraction pattern. So we have the NAGM electrons in electrons, and we can use the formula lambda equals H over 2 E. Okay, E has to be in joules, so H over 2 times mass is 9.1 times 10 to the power 1, and the electrons 3 times 3 power 3. We have to make that into joules, so 1.6 times 10 negative 19 is 2.24 times 10 to the power minus 11. And frequency is C over lambda. C over 2.24 times 10 is 11 is 1.34 times 10 or 19 hertz. 1.34 times 10 to the power 19. Energy level diagram for hydrogen atom is shown in the figure below. First state, hydrogen atom could be excited to the N4 state in one step. So the N4 state has 12.8 electron volts. For that, you just need to provide hydrogen atom with a photon of energy 0.8 electron volts. It's the possible photon energies that could be emitted as the atom goes from N4 to N2. For N2, yes, no. So 3 possibilities. So we have 2.6 electron volts, 0.7 electron volts, and 1.9 electron volts. Yeah, 0.7, 1.9, 2.6. And then we come to the spring question. And you had to draw a force versus compression graph and use G equals 10. You can draw the forces. X is 0 and mg 0.3 times 10, 3, 6, this would be 9, 13, 17, 19. And we have to draw the graph, newtons and meters. This 21, 40, 60, we can go by 20s. Start at 0. Millimeters, right? 0.02, 40, 0.04, 0.06, and then we have 0.08, 0. Now we can go 2 newtons, 4 newtons, 6 newtons, 8, 10, 12, 14, 16, 18, and 20. So it's 3 newtons, 4 hours, 6 newtons, 0.06 was 9 newtons, and around 68 is 13, 0.07, around there. 8, 7, 70, 0.075, 17. So on this line, 17. And then for 0.08 is 19. 19. Arrow bars is 0.002. Can't do it accurately, but just, and make so it's horizontal. This one. Yeah. And we also have to draw lines of best fit, which, okay, that's how it goes. Zero, just spring A, I'll do call. And for spring B. But these will, we can extrapolate them. Same goes for this. Determine the spring constant of spring. Okay, again, just rise around the gradient. Okay, let's pick 150. For KB, it's a bit more complicated. Yeah, so we can find K for A plus B first, 10 to 500 meters. Then we can find KB by KA plus B minus K. So we found that this is 500. We previously found that this is 150. It will be 350 a second. The area under the force versus compression graph or otherwise determine the potential energy P E A spin A. Finding this energy area. So 0.5 times answers they extrapolate to if you have to go here for the full potential energy, you can just get this area. So once you extrapolate to here, 0.08 goes to 12. So 0.05 times 0.08 times 12, which is 0.48 joules. And then we're finding the total potential energy with A plus P. We can first get this, and then this area. Yep. 0.02 difference. Okay. So half A H plus half A plus B H. 0.5 times 0.06 times height was 9 was 0.5 times 9 plus 19 times 0.02 0.55. The work done to compress string B when the spring system is compressed by 0.08 millimeters. So for potential for B and potential A plus B minus the potential we found for A. This was 0.05 and A was 0.48. 0.07 joules. Explain how this type of spring system could be used in car spring suspension system to enable how to negotiate small bumps and more severe bumps on the road. Single spring A could provide suspension for small bumps combined system A plus B could provide suspension for more severe bumps, more severe bumps and small bumps. And that's all.